So in this video we will be discussing about context-free grammar, right? So what does grammar means? Grammar is a set of rules that are used to construct sentences in a language, and those sentences are often referred as strings, right? Now what is context-free grammar, right? Context-free grammar is basically the grammar consisting of four things, right? First is this variable, finite set of variable, and second is T, terminal, finite set of terminal. Now what is finite set of variable? This is the variable which can be replaced by any terminal or any other variable and often denoted by capital letter. And finite set of terminal is any terminal which cannot be replaced by any variable, and this is often denoted in a small letter. Right. Now third thing is production rules. These are rules on basis of which the sentence is to be created. And last one is start variable. Variable at beginning. Right. Now variable can be, right. Now suppose, let's take an example. I have alpha goes to beta, right? So in left there is only one variable, and at right I can have variable or terminal, right? And variable union terminal, either variable or terminal, and asterisk means combination of that union, right? Either variable or terminal or the combination of the two, right? Now let's take a start variable. So a start variable is the variable which is at the very top of left hand side, right? For example, I have S goes to 0 S1, right? Here S is a start variable, right? And this capital S is variable. My variable is S, right? My terminal is 0, 1. This is my terminal. And suppose S goes to epsilon. So epsilon is also my terminal, right? And this has two production rules. This is one and this is second. So it has two production rules. And then suppose, let's take an example. As S is variable, so I can write this thing as 1. If I will write this as 0 S1, and here S, in that S I can insert again 0 S1, right? And suppose I will terminate it by lambda, right? I used epsilon or lambda for termination, right? So I will get 0, 0, 1, 1. Now in form of tree it can be represented as S, right, gives 0 S1, and this S gives 0 S1, and this is given by epsilon. So it will ultimately be 0, 0, 1, 1, right? And the language generated with help of this grammar will be 0 to the power n and 1 to the power n, where n is greater than or equal to 0, right? Now let's discuss about derivation trick. For that I am erasing this, right? So derivation tree is sequence of steps follow to generate a word or a string from a given grammar, right? So derivation 3 is nothing but sequence of steps follow to generate a string or word. Suppose I have grammar given as E goes to E plus E, or E multiply E, right? Or E is equal to E, and at last ID for termination, right? Now, what are these? This is my start variable, right? These are my set of terminals, right? Capital E is my set of variables, and these all are my production rules, right? Now suppose I have a word that is ID plus ID multiply ID. Does this word belongs to the language, does this word belongs to the grammar or not? So how I will find? I will use first this one. So E, this production rule, E goes to E plus E, and then here I will insert this production rule, that is E star E, right? So ultimately I will get E plus E star E, that is ID plus ID star ID, because I have inserted ID to E, right? And that's how, because I want to terminate my E, right? So I can say yes, this word belongs to grammar, right? And these steps are derivation. This representation in form of 3 can be given as E, this as E plus E, and this will be given as E star E, right? And then this is terminated to ID, this is also ID, and this is also ID. So it can be written like this. And then we will discuss about ambiguous and unambiguous grammar. So I am erasing this. Right. So discussing about ambiguous and unambiguous grammar. So for ambiguous, there exists more than one derivation for any word that belongs to that grammar. Suppose I have a word and there are multiple derivations, so it will be my ambiguous grammar, right? And unambiguous grammar means only one derivation for that word from grammar. So this will be unambiguous grammar, right? For unambiguous grammar, there exists exactly one derivation for any word that belongs to that grammar, right? Now suppose I have a grammar S goes to S, A, S, A, right? And I have a word, let's say A. Now whether this word belongs to that grammar or not, I will see. So derivation can be given as I have S, A, and then in that S I can insert S, A, and here for termination I will insert here A, right? So I can see, I can get triple A, and this is leftmost derivation 3, leftmost derivation 3. Now I can also do this in another way, right? I can write this as S A, but this time I will use this one, right? A S and this A, right? This is also leftmost derivation tree, and for rightmost I can write as S A S, and this can be written as A S, here A, or this can be written as A S or S A and here A. These are rightmost derivation tree, right? So this way we can say this grammar is ambiguous grammar, as it has more than one derivation tree, right? Multiple derivation tree. And now let's take an example of unambiguous grammar, right? So suppose I have this grammar. S goes to AB, right? A goes to A, capital A, and for termination B, B goes to A, capital B, and this is small a, right? And I have a word A, B, B, A. So for making the tree here, I will use this S, right? A, B, and for A I will use A, and for B I will use B, B, this one, right? Sorry, this is B, right? And here I will terminate this as B and this as A. So I got my A, B, A, B, B, A, right? And this is unambiguous grammar because I have only one derivation tree for this word which belongs to the grammar, right? So that was all for today.